Today I'm going to talk about my PhD project. It's an attempt to improve system integration on a fuel cell micro-CHP and to reduce energy demand in buildings, in dwellings, basically. So this is the research question: how can we exploit the benefits of fuel cell micro-CHP in a domestic environment, reduce CO2 emissions and costs, where we have varying demand for electricity and heat in dwellings. So, some background: two different types of fuel cells are used in micro-CHP applications. This is the solid oxide fuel cell and the proton exchange membrane fuel cell. And we have chosen to go for optimization methodology because there are many studies on simulation of fuel cells in buildings, but a few only on optimization. So this is a schematic that shows one of the possible configurations, and we're examining many configurations in this project. The methodology involves building simulation and optimization techniques. In other words, we use the building simulation software to calculate heat loss and electricity requirement, and then we have different possible configurations in our models. So we can then calculate, we have as an objective function the minimization of CO2 emissions, and we're able to calculate fuel cell capacity, boiler capacity, how they operate during periods of time, if we need storage or not, and size of the storage. And by using this model, we can evaluate different scenarios, even scenarios in the future. This graph is from some of the scenario predictions we did for future buildings and how systems can work in there. These are some typical results. I would say the main findings are, in our models, the fuel cell capacity seems to be between 2 and 3 kilowatts, which is okay because most of the commercial products are in this range. And the auxiliary boiler capacity can vary from 7 to 22 kilowatts. And in all of the models, when we had storage, thermal storage, we were able to get more savings because the storage, as Jonah also said, reduces the peaks, and we can store some energy from the fuel cell when thermal demand is not needed. We can store it in the storage and then use it in the system. Reductions range from 10 to 15% by using fuel cells. Obviously, cost is an issue, but in this stage we haven't considered cost yet. I think one of the main conclusions is fuel cells work okay in dwellings, but we've seen that it's better if you do other things first in the house, such as improving insulation and then work on the system. So what we're doing now, we're expanding the model from just looking at it as a box. We're going into the fuel cell to find ways to utilize different heat streams between the process units, because fuel cell micro-CHP needs many processes to deliver electricity and heat. So we're looking if there are any other ways to utilize heat from the stack, or heat from the auxiliary burner, or heat needed from the reforming process in the buildings. And that's all. Thank you.